Let's talk about thermally conductive compounds. What is a thermally conductive compound, how they are made, and how do they work? Thermally conductive compounds are produced by dispersing into a base resin, a thermoplastic base resin, a large amount of conductive filler. It can be graphite, which is also electrically conductive, or ceramics, which are electrically insulative. The products have very different performances, and we are going to find out this during this presentation. First of all, not all matrices can be used for this purpose. You need a specific range of plastic matrices capable of swallowing huge amount of fillers and capable of resisting to the heat exchange. The amount of filler can be really very high, up to 70% of graphite and up to 85% of ceramics, which is quite a lot. You need a very good dispersing technology in order to achieve the best performances when it comes to thermal conductivity. So filler dispersion is absolutely fundamental, but what is even more important is to obtain the best compromise between thermal conductivity and all other different properties that compounds must offer, as mechanical resistance, chemical resistance, temperature resistance, and so on. That's where the know-how of the compounder lies. Thermally conductive compounds are becoming more and more common in more or less in every kind of sector, because there are some big trends which are common to different industrial sectors, like heat buildup in general, which is strongly correlated to miniaturization of electric circuits, connectors, and so on. Where do thermally conductive compounds find application today? In electronics, in the electric mobility, where a huge amount of heat have to be managed. In the LATI industry, where electrically conductive, thermally conductive compounds, are used to mold heat sinks for LED lamps. Then we have the general purpose automotive, sensors, and medical, just to give you an idea of all the different applications that can be produced using thermally conductive plastics. Let's talk about some fillers. The fillers are the real key for thermally conductive compounds. The matrix is important because it is the vehicle keeping all the filler particles together, but it's the filler which is actually transporting the heat. So thermal conductivity of the compound is strongly correlated to the performance of the filler in itself. The best performing, the most effective fillers are graphite and boron nitride.